So let's talk about some tips and tricks for Mini Project 5. So first, we're going to be working with lines in this mini project. Remember, the equation of the line is in the form of y equals mx plus b. With our lines, x is the independent variable and y is the dependent variable because it depends on x. So another way to think of this equation, particularly for applications, is that our dependent variable, which is y, or plays the role of y, is equal to the slope times the independent variable, typically x, plus b, or the y-intercept. So we still have m and b. So just a couple of examples. Identify the independent and the dependent variable. Temperature versus time of day. Does temperature depend on the time of day, or the time of day depend on the temperature? Typically, when you have time, that's the independent variable. So if it's noon, the temperature is going to be warmer than it would be at dawn. Motivation versus week of the semester. So usually your motivation depends on how far in the semester we are. So your week of the semester would be independent, motivation would be dependent. Season versus chance of rain. What depends on what? Our season is our independent variable and our chance of rain depends on that. Okay, so that's just some practice, and as you'll see in the mini project, that'll come in handy with the scenario that you're given. So one thing to notice is, let's say we have motivation versus week of the semester. So typically when we graph these, let's say week 1, 2, 3, 4, 5, 6, 7, 8, and we have our motivation. Not sure how you quantify motivation, but whatever you want to use there. Percentages, maybe you have 100% at the beginning. Later on in our graph, so when we're labeling this, we can label this week of semester and motivation. So when you're labeling a graph, you need to label your horizontal and your vertical axes. Typically, the independent variable is your horizontal axis and the dependent variable is the vertical axis. Okay, and usually motivation looks like this. I wish it went the other way, or I wish it stayed the same, but we've all been there. It goes down as the semester goes on. You got to bring yourself back up to keep going. Okay, so that was just a lesson in labeling the horizontal and vertical axis. Okay, so a scenario given that we'll use in this example is, how does time spent on a test correlate to exam scores? So we've got two variables. We have time spent on the exam in minutes and the score. And I broke this chart up. You want to read these, pretend these were all stacked on top of each other, but in order for this to show up on the screen, I had to break it up. So we have our time, which is our independent variable, and we have the score, which we're wondering is our dependent variable. Does our score depend on how much time was spent on an exam? So you're given a table like this, and if you're asked to make a scatter plot, the x is typically your independent variable and the y is typically your dependent variable. So this right here would be an ordered pair of 77, 90, where 77 is playing the role of x and 90 is playing the role of y. Okay, and you can continue on. Let me pick another one. This ordered pair would be 44, 80. So when you're asked to make a scatter plot, I have it done here for us. We have time in minutes, and then we have score on the exam. Okay, so this would be the plot, and you would make this by doing the XY pairs. There's a template in the mini project for you to use. Line of best fit. So in problems like this, the line of best fit is typically given. I could kind of draw it this way. So there's some negative correlation, probably negative correlation going on. Okay. So the line of best fit given for this problem, this is provided, so you won't be asked to calculate it for this problem, is grade is equal to negative 0.12 times the time spent on the exam plus 87. Okay, so from here we have our dependent variable equal to our slope times the independent variable plus 87. So here our slope is negative 0.12, and as a fraction, if you use your calculator, this would be negative 3/25. And the y-intercept would be 87. So from this, you can pretend or take a look at this as negative 0.12x plus 87. Okay. And so if we're going to graph this, I graphed it here, you would start at 87 and then you'd go down 3/25. Next, there's some calculations or some problems that you can answer using the line of best fit. So let me write it here for us that our grade What would you expect a student's score to be if they spent 57 minutes on the exam? So they're asking for grade, and they're giving us 57 minutes. So what you would do is you would take your grade, plug in 57, and if you simplify the right-hand side, you would get the grade that's expected on there. I think this is 80.16. If a student wants to score a 73 on the exam, how many minutes should they spend? So we know the grade that they want. We're looking for time. So you plug 73 in for grade and solve for time. So this goes back to solving equations. I believe this comes to 116.67 minutes. Okay, and according to the line of best fit, what would a student score if they spent 0 minutes on the test? So there's a couple of different ways to think about this. 0 minutes means that our time is equal to 0, or another way to think about it is it would be the y-intercept. So they would score an 87. And how do you interpret the slope? So remember that slope is a rate of change. So if we're dealing with slope as negative 3 over 25, we would go negative 3 on the y-axis and 25 on the x-axis. And I'm just drawing it here to show you. So your score goes down 3 points for every 25 minutes longer you spend on the exam. That leads us to, is this a good model? Take a look at the slope, the y-intercept. A giveaway here is that if you spend 0 minutes, you would get an 87. Is that true? Probably not, so that would be a limitation of the model. But there could be some truth to it too, that possibly students who are confident in the material and know the material will score better and spend shorter amount of time. But sometimes students who do really well and are really thorough take a longer amount of time. So it just depends. And so discussing any limitations or a good model or not, take into account the line of best fit, the data points, and what it's telling you.